Hi guys, just wanted to have a talk about this transistor matching circuit that I've made here. There were some other YouTube videos online based on this transistor matching circuit by Ian Fritz. I noticed there the other day this circuit here. So there's a PNP version and an NPN version, and it basically sets up like a differential amplifier here, and just compares the voltage here across these two resistors. Any difference there means that there must be a difference in the transistor. So one of these transistors becomes the reference transistor, and you just keep swapping out Q2 until you get basically these voltages exactly the same. Now it relies on these resistors being very accurate, which is fine. We can put a trimmer resistor in here and measure the resistance and adjust the trimmer until we get an accurate result. The circuit wasn't bad, and I didn't have anything particularly that I didn't like about it. The only thing I thought maybe we could improve on was that if we set a fixed base current into each of these transistors, that way we know that the base current is fixed, because if we just leave it like this, we could actually get a different base current into each of these transistors, and we don't really know what they are. And then if the gain of the transistors is different, it just sort of, there's a few loose ends and variables that aren't really taken care of. So I thought of, if we just change the circuit just a little bit to something more like this, where we've got basically a set up a current mirror here, and then we can basically just create another current reference from this current mirror. So we've got one here and the second one here. We can set up, this is like a variable resistor here. So and on my board here you can see this is the first, basically just the bias current, or in the reference current that's set up. It's about 1.5 milliamps or so, just to establish a reference for these other two transistors, which are going to be the current mirrors, and you can sort of adjust them here by adjusting this emitter, the emitter resistance here, this 77K. So basically what I've got here is a 100K and a 1K, or it might be on a 100, so 100K and a 100 just in series, just so I can get fast adjustment and fine adjustment. And you'll see later how I'm using that. So that's for the first transistor, which will then be driving. This transistor here is the reference transistor, and then this is the test one. So you just leave this one in, and you just keep swapping this one out until you get your voltage between this point and this point being the same. So very similar principle to how the other Ian Fritz circuit works, where it's just comparing the voltage above these emitter resistors here, and this is just my trimmer resistor, so I can get the resistance between this point and the center of this point, which is ground, and this one and basically ground exactly the same, and we'll go through that a bit later. So yeah, so this is the rest of the circuit. So that's those trimmer resistors that I just talked about, and then you can see here that both transistors are still fed with the same current. So we feed both of these transistors. One is the reference transistor, and one is the test transistor. And you can see here, reference transistor at the moment I've set up in my LT Spice model. The reference transistor has a beta of 100, and the test transistor, let's say for instance it wasn't going to be matched, so it's got a gain of 110. And as you can see, this affects the circuit because basically you've got about just over 1 milliamps through the reference transistor, and the test transistor's got more milliamps flowing through it, and because of that we'll have a mix match in voltage between these 2 points here. In this case it's about 63 millivolts, and that's because they don't match. So these are some of the values that I've basically got. This is just a 100 ohm trim pot across here, 560 ohm resistors there. At the moment I've just set it up for about 1.5 milliamps on the breadboard here. This is what I've got set up here, and yeah, we'll just go through that here on the breadboard now. So this is my DC power supply. So at the moment I've just got it set to about 12 volts. So we can just turn on this meter here and just double check that that's what we've got. So I'm just going to plug in these leads off my multimeter just into here. And this is also a ground reference down here. So basically 12 volts. Yeah, I'm not going to fiddle with that and get it exact, but it's close enough. So yeah, so we know that that's set correctly. The next thing that we want to do is just change this to resistance here, and we're just going to check between. We're just going to take these transistors out for a minute. So just take these ones out, put them down, put those down there, and we're just going to test between. So the top of that port there to ground, and we've got about 575 ohms, and then we're going to test between the top of that one and the top of this one. Sorry. And yeah, we've still got about 575 ohms on the multimeter. So yeah, so you would just keep adjusting this pot down here until it's basically exactly the same. And if you want to make it easier for yourself, you can just set up two multimeters at the same time and just trim them out. We might actually just do that quickly. So I'll use these 2 meters here. I just need to quickly change this over to here. Set this up on. Set that up on ohms. Plug this one in over here. Set it up on ohms as well. Turn it on. And yeah, so I'll come back to here. So this one here. And then the second one. This way, if we do it like this, we can actually see both meters at the same time. Otherwise, it's a bit of a mix and match. You've got to put one in and pull one out, and until you get it spot on. So that could take quite some time, and yeah, be a bit frustrating if you can't get it exactly right the first time. So yep. Alright, so I think because it's in the breadboard, it's moved around a little bit, and the resistances aren't quite as equal as when I was doing this earlier. So that's okay, we can just trim these to being equal now. So I'm just turning the resistance up because the left meter is basically the left side of the trim pot. So as I turn the left one up, the right one should come down, and it looks like we're getting closer. We just want to get these to be equal. So it looks like about 607 or so is going to be where we're going to be needing to be at. Just there we are. So now you can see both the resistance there is exactly right. So that trim pot down the bottom here has allowed us to do that. Alright, so now if I take these back out again and put our transistors back in like that. So transistors are back in. Now I've set up a way that I can measure the base current. So if I'm going to measure between this point and this point here, so basically this point and the base of the transistor on this one, and this point and the base of the transistor here, we can basically check the milliamps flowing into each of those is exactly the same. So I'll just reconfigure these meters again. So this meter is going to go over to milliamps, sorry, milliamp microamp scale, and do the same on that one. And then this one here on the milliamp microamp scale, and then I'll hook these up. So we've got there to there, and wouldn't you know it, your batteries have gone flat. So let me just switch that meter out. Right. Just switch this meter out quickly. Put this back on here. Right, there we go. So now we've got both of our meters in there. The first one's on there. Now the second one just needs to be wired up. So put this one. So we're going to put our meter there and in here. Right, there we go. And like I said, it's all on a breadboard, so it's not going to be exactly perfect, but once it's made into a proper circuit, it's going to be fine. So the left one is the reference, so 8.7 microamps. That was done by adjusting these two pots here. So yep, we're going to use that as our reference, and we're going to come over to here. The 8.7 microamps was used to generate a reference current between this leg of the reference transistor. So yeah, so once that's set, we're set at 8.7. So now the other one we want to set at 8.7. So I can just adjust this trim pot here, and we'll just adjust this until we get 8.7 on here. So that way we know both the base currents is exactly the same. So a little bit more. There we go, 8.7. So now we know that the current flowing into the base of both these transistors is exactly the same, and the only thing that can differ now is if the gain of the transistor is different, which is what we're trying to test. And so yeah, so now if I just plug on my multimeter now between this point here and this point over here, which is basically on the circuit, it's between here and here.